How's everybody doing? For this week, I have something cool. I have a list of different resources we're going to check out. Some that describe data structures, some GitHub repos that are for describing data structures and algorithms, some that are example projects illustrating like common uses of object-oriented programming, some common uses of data structures, and some of both. So hopefully it should be a fun tour through this stuff. Shouldn't be a very long video, just showing you what each of these are, and then for this week check them out and post in the discussion boards about them. So the first one is this list of the most common data structures and what you should know. You know, this is for your next coding info interview. This is from freecodecamp.org. This is a website I've seen and used resources from before. It's nice because it goes over data structures, the idea of why they exist, storing data in an organized form, employee salaries, stock prices, grocery lists, telephone directories, right? Any kind of scenario data in some kind of format, and lists through the common types that I've always mentioned. You know, the arrays that all data structures are based on, stacks, queues, linked lists, trees, and so on. So I'd like you to read through all this. It's a good set of describing arrays again, like we did in class. Stacks, pushing items onto the top of a stack, popping items off, checking to see if the stack is empty. Remember, that's the only way to access it. What people might ask you about in interviews related to stacks or queues and so on is in here too. Good stuff just to read over to try to understand why these are so important. That's kind of the main point of this week, is understanding them, making sure we have them solid, what a stack is, where we can put stuff on top and it pops back up, like cafeteria tray style, used for very quick memory access, like one of the fastest, easiest structures to work with. And then we have something like a queue, where a queue, we put items at the end and items come off the top or the front, like a ticket line, okay? And those two structures are similar. The queue implements the first in, first out method, whereas the stack implements the last in, first out. But those two, and working with those two, are common ways of managing data elements in some kind of a order, whether it's chronological, that kind of thing. Next is the linked list. So instead of having this structure where you're putting elements on, taking them off, or pushing them through a list like a queue to get tickets or food or something like that, a linked list is similar to just an array, as in there's a series of buckets, right? So a basic array is just a series of buckets of strings or integers or whatever. A linked list is a chain of nodes. There's a pointer to each node, to the next node, to the next node. The idea here is when you're implementing an array, you're probably going to read in a bunch of data. Let's see, we're looking at polling data. Let's read in from the database all the votes, tally how many for this person, how many for that person, etc. And then you get the results at the end of the voting period, okay? A linked list is something like file systems where you might have this long coordination of database files, like think of SQL Server, MySQL, Postgres. Any of these database systems have these huge MDF or LDF files, like the master database files or the log database files, and they get really big, gigs and gigs, right? You shrink them and you can partition them and whatever, but in terms of on disk, there's a MDF file that started when the database is started, then you might install SAP afterwards, or you might install BizTalk afterwards, you might install some other application afterwards, and then the database has to get larger, so it points to another part on the drive where the other part of the MDF is, and this is how files get fragmented, right? Things like linked lists are used to implement those kind of data structures that could go on towards infinity, right? You could have different parts of it on an iSCSI SAN array of drives. You could have 100 drives. These 100 drives are 100 physical drives or one logical drive. And there's like a linked list. There's one huge file that goes across all these 100. I wouldn't recommend doing this all in one file, but you could. Excuse me. You could have 100 physical drives in this linked list, and nodes that just point from part to part of each drive, and it keeps going. Alright? So, if you were Santa Claus and you had to store the Christmas list of who's good and who's been bad, you might have to implement this on one drive and have one list. Right, in that case, possibly it's okay. Other than that, you probably want to split these lists up. But things like file systems, large database files, you don't have much of a choice. So, this linked list is similar to an array. The only difference being that in general the array is a series that's right in a row in memory. These could be all over the place. They could be bidirectional, single directional. So you could insert at the beginning, at the end usually, or search through for certain elements. To clear out duplicates, cleaning the data up, defragmenting and moving them. Next is graphs, and a graph is a set of nodes that are connected by a point. So A is connected to B, B is connected to C, C goes back to A. So these are kind of like logical structures to learn in your mind, sort of. There's implementations we'll look at in JavaScript and so on and so forth for each type, but learning what a graph is versus a linked list or a tree or a stack, or really learning the logical, abstract ideas of what they are. So the graph is some edge, a pair A, B connected, and they have some weight or cost or some value, so you know how to navigate these graphs. So this is a way to navigate data, and a tree is similar to a graph in that there's A to B connections, but a tree has a starting point and some usually type of termination, like in this case a tree has endpoints. So you can use this as a data structure in many cases. Most, I dare to say, depending on how you classify events, almost anything in terms of an application, like they say here, using artificial intelligence and complex algorithms, almost anything can be represented as a tree because some decision is made. Like in this case, you have spot number 1, a decision is made to go to either 2, 3, or 4. And if you happen to go to 2, you're done, you're stuck with that. If you pick 3, then you have more options. So think of like when you go to purchase a car, if you're going to go buy a brand new car. So let's say, as an example, you're going to pick a new BMW, just random choice of car. Purchasing vehicles would probably be something you could classify as a tree, and you might even see that in terms of how navigation works. So we're on the BMW site. There's another SUV. Everybody SUV. Look at the grill. Why does the grill have to be so large? So BMW vehicles are in a decision tree in terms of there's X class vehicles that are SUVs. There's number class vehicles that are cars, and then Z's that are convertibles, and M's that are sports, I's that are little electronic or large electronic, but I's are all electronic drive. So we could have this decision first of whether you're going to purchase a SUV style, car sedan style, or a roadster. If you pick the car sedan, then under the car sedan you can choose between gasoline drive cars, the 2, 3, 5, 7 series, or the I, 3 or 7 series. If I were you, I would choose gasoline 3 series. Just starts a good sized car. Got to get up and go. Got like a 2.5. Get around 200 horsepower, 6-speed. You're good. But anyway, that's not the point. The point is, you start at the beginning. You choose either an SUV, option number 2 in your tree, and then you're done. A sedan, car type, option number 3. And you have sub choices, or option number 4. Your roadster, your Z car. So if you pick 3, your car sedan style, you can either purchase a gasoline or electronic motor. So the idea is, there's some route with parents and children. You could classify lots of applications like this, right? You open up Microsoft Word. Either you start a new document or go to open an existing, edit a document. Then it opens the window to choose where that's from. You close, either save or not save, right? So the idea of a tree is, this is something that you can use to visually represent process flows also. There's special kinds of trees based on how searches work. Those are coded as like kind of search algorithms with those trees. So there's more to learn about those specifically. But the idea of understanding that structure is important. You can use that to draw out how to do code also, and then represent that with ifs or case switches and so on. And the hash table, this is some way to represent a set of data where you've got some cardinal value, cardinal order 1, 2, 3, 4, a set of hash items. In this case, it looks like there's 17, and those have a key that's unique, and then whatever data. So this could be something as simple as student IDs, right? Everybody has a SID, a student ID. Mine is JPC ST52. So that was my key, and then whatever data that's relevant for me, name, age, etc. Likes, dislikes, that kind of stuff. That all could be stored in data. That could be a large amount of data that varies, and maybe we know that for some people, we don't know it for others. We don't know hobbies or likes or dislikes for certain people, and that part of the data is empty. But there's a key that's unique. We all have a unique student ID. That's a hash table. The idea of a hash table is to have some key, some hash, that we can easily look up, try to index, figure out some way to make those keys fast to look at. But it's one of the quickest data sets to work with. Like if you look at JSON objects, the basic JSON object is a number 234, server address, client name, job name, Postgres, etc. It's company, my company, key value, 2 items. So in this list, company is only going to show up once. Company contacts is only going to show up once. Order number is only going to show up once. Date is only going to show up once, right? So that's the key. That's the idea, that the hash table might be, depending on how it has to be represented internally, there might be a linked list to store it on. Hopefully not. Hopefully it's all organized, one part of memory, quickly. That's what you want. The set 1 through 17 is all in RAM in order. And I can use that key to quickly look up more data on the other side. Okay, so hopefully that makes sense. It's a simple data structure, but important. So that's the idea of that link, of reading that one over. This is just another link to a GitHub repository that the author of the JavaScript data structures book maintains. In addition to the one for the publisher, it looks like the author also maintains this one here that has some good examples of how it should run, just so you have it. My assumption is that you keep this stuff after this class to go back and reference it when you need it. Okay, so, and this stuff is all out there. It's free to have, so that's cool. So next is some everyday use of object-oriented programming and data structures. The first one is super cool. This is an example of using SAP Business One. So SAP Business One is like the small to mid-sized version of SAP. So SAP, as we probably know, is an ERP, one of the world's largest ERPs. So SAP is one of the world's largest ERPs, which stands for Enterprise Resource Planning System. So the idea with this is, I've written order systems, order e-commerce store websites, like buystuff.com kind of things. I've written purchase order systems. I've written payroll and time entry systems. I've written stuff to manage manufacturing hardware and take orders from the order.com website into the manufacturing system and process the orders. Take the time entry information into that payroll system. Take the raw material costs when we made those parts and get the sale price and take away the raw material costs and the labor costs. Try to get so that's the idea of what an ERP is. It's taking all those pieces together, right? So if I take all those components of a company and flow all that data together at once, I can see quickly if things are profitable or not profitable, and I can make changes on the fly. So this is one of the huge advantages of e-commerce. So all of a sudden, and we see some bad side effects of this, but all of a sudden toilet paper is in high demand. So the price of toilet paper automatically goes up because the software realizes that people are buying it. At the same time, travel, luggage, and swimsuits are going down in price because nobody's buying that stuff. So all of a sudden the prices of those goods drop because nobody's purchasing them. This is a good dynamic way to efficiently take care of your inventory. Make the price really low if no one's buying it, to get rid of it. And if people are buying it, make the price high to be profitable. Obviously, there's limits to what you want to do with that. But the idea is, if you have an e-commerce system that's set up with an ERP system, and that can manage all that business flow, you could do that. And when things are selling like hotcakes, automatically reorder them. And even though these traditionally were for large enterprises, you'd get something from SAP, you'd spend hundreds of thousands of dollars, you'd have a 12-month implementation, 18-month implementation, it costs all this money, blah, blah. That is changing. SAP has a solution called SAP Business One. Okay, this is not a large enough screenshot. But SAP Business One is for small to medium-sized businesses. And with it, you can log in to a web-based interface. Let's see if this shows a full-size view. And run either a desktop native version or a web-based version of a simplified version of SAP. So, somewhere that's bigger than what QuickBooks does. QuickBooks does some aggregation into a dashboard when you open it of what's going on with your accounts, what you owe, and stuff like that. Imagine that on a larger scale to try to do that for the business. What's aging in terms of accounts receivable? How are we doing on raw materials? What's our order analysis? What's our forecasting? That kind of stuff. So trying to wrap that into a package that's affordable for smaller businesses. So, like I said, traditionally SAP implementations could be hundreds of thousands of dollars. SAP Business One is like, it depends, I think, on a couple bit of variables, but I think you can get it for something like $50 per user per month, which is pretty cheap. for something that can run your whole business. So this second section, this everyday use of OOP data structures, this SAP Business One is showing how to interact with that. So lots of businesses may purchase access to SAP Business One, but they have an ability to access an API and add extra functionality to it, because SAP Business One, just like SAP or any other ERP system, whether it's from them or Oracle or an open ERP, it starts with kind of like, I don't want to say generic business, but it starts with a model of how your business should run. And either there may be outside systems that you have to take data from to pull into here, outside pieces of hardware that you have to connect to this system and interact with, whatever that may be. You may have to do something to connect to SAP Business One and put data in there and take data out. So it may not be an end-all be-all solution for everything. Maybe at some point it could be, but there may be hardware pieces or interaction, import, export parts of the system where you get data from the government, or you have to send data to the government or to your third-party accountant, right? Those other parts you might need to go in and manipulate it. So this shows using the SAP Business One API. So it's kind of cool. It's a very simple example. You can just look at it directly in GitHub, actually, because it's just a couple pages, or excuse me, a couple classes. So there's the main class here, and what this shows is making a server connection in static void main and making a server connection to SAP Business One. So that is a special class, right? SAP Business One, this stuff isn't built into .NET. There's a special namespace that they have, and this server connection class is object. So this is an example of object-oriented programming. In that same namespace, there's a class called server connection. So if you're going to do interaction with SAP Business One, one of the first things you're going to do is set up a connection to the server and connect to it. This is similar with things like Microsoft SharePoint. These applications, SAP Business One, SharePoint, Microsoft Dynamics, there's databases and then services running on top of those databases, and then APIs that you can access for those services. So you're not supposed to go, in most cases, directly into the database and mess with it. Okay, so that might mess up your support, that kind of stuff, if you do that. Okay, so the idea is they have some kind of an API, like in this case. We get a reference to an SAP object for the company itself. When we make our server connection class, we say, alright, let's get a reference to the company. When we connect, we have all of these attributes from another object. And that other object is our config file. So here, it says we need to get the server, we need to get the company DB, the database type is Microsoft SQL Server 2012, database user password, username password for SAP itself. Those are all values that will be stored in our config file. So the idea would be, if we're an SAP Business One contractor or developer, we have this class defined, and then in each client or each application within each client, they may have different usernames, passwords. So there might be some part of SAP that connects via like a Rockwell or an automation factory PLC device that has a separate username and password. Then there's this username and password for the accounting software. Maybe we do use QuickBooks or Peachtree or something else for some reason to import export data, and there's a separate username and password for that. We want to have all those separated as separate server connection instances with usernames and passwords, so we know if something goes haywire with one, we know whose fault it is. Also, the permissions are different for each one, right? Maybe different, So many reasons why you have to do that. But this is just a simple example of why object-oriented programming is important to understand what's going on here. So that's how you would do API interaction with SAP Business One using objects. So another one, this is super cool. This is called the Microsoft Common Data Model. Microsoft Common Data Model. The idea here is Microsoft knows, just like any other large development company would know, that most applications in your business are going to use a lot of similar objects. So things like accounts, contacts, leads, opportunities, products, um, all of those are going to exist in your business, in a business that I would own, in um, Walmart, McDonald's, Mercedes-Benz, BMW. Everybody has accounts, appointments, contacts, phone calls, sales, service, marketing, etc. So instead of me and you and your cousin and my cousin all defining what an account is, why don't we just get some generic account definition that is a common language for businesses to use, so that we can have something common across sales, service, marketing, operations, finance, talent, and commerce, so we can have interoperability between businesses. If we want to sell our products, my products to you, if we're going to do some kind of co-branding, marketing, or co-operational piece, how can we send data back and forth and in such a way that we both understand it? So this is kind of like what you would have for EDI standards, so I know what order acknowledgement or delivery confirmation is. So this is like just a whole set of objects. So this is interesting also because there's a lot of work that can be done as data scientists and analysts in terms of defining how businesses, healthcare organizations, everybody defines what objects are, right? Like everybody has some definition for medical records on the state. I've worked on state and federal medical records applications that move data back and forth. Every state, everybody has different definition for how stuff works. Every CRM has a different account. They're close. They try to get closer, but there's always minor differences. So something else for you to look at. So there's samples that you can check out in some different programming languages. So pretty cool. This is another one on GitHub that uses objects, and it is part of blockchain, basically an implementation of some patterns that would be used in blockchain for user authentication. So if you know anything about this kind of stuff, the idea is a blockchain network has peers that authenticate who you are. The convector is something that sits on top of that to help with validation of that via X509 certification certificates. This is another series of objects, basically. Something else cool to check out, something hot that's going on in terms of programming right now, is blockchain and integrating that into applications. So I figured that'd be cool to check out. Next is a healthcare example. Again, for each of these, I didn't want to go through and show implementing all of them, opening all the code and looking through everything, because then this would go on for quite some time, and I thought, hey, this is something you could do this week. Check some of these out. This is all code you can download, open up in GitHub Desktop, right, and get running, and all of it comes with easy to use instructions. Every single one of these is like 2 or 3 steps. So this is a healthcare example application used to quickly prototype, and this is super cool. This could be something to build a project on. Logging in, registering people. Here's a dashboard. Goals, setting goals. It's a nice looking interface. All this is already there for you to start with and check out. So again, something cool to download and see how it works and maybe build upon. But again, the idea is a whole set of objects with data structures on top of them. These ones are, these two links are more expansive content in Python. So something else that I had wanted to do in class was to get deeper into Python. We didn't do much besides class definitions. These guys do a better job than I could do anyways, in terms of time. So this practical business Python, this is really super great. This mentions all kinds of ways that you can use Python in terms of data visualization, network automation, stuff that you do in business, stuff that I do. Like I use this kind of stuff, like WSL, Windows Subsystem for Linux, which I'll talk about more later. Like I've worked with this stuff specifically. It's really cool. This guy has all this code. Oh man, good stuff. Let's see. Like just tons of things that you would use day to day for networking, changing files, like splitting PDFs, doing stuff with Excel, PowerPoint, adding charts, like tons and tons of useful actual business code that you would actually really use. That and the blog content I think is great to check out. And this other author has this first course on data structures in Python that I thought was really, really excellent too. I would have done, if we would have had more time in class, I would have done probably like a class or two on this itself also. These two sections probably more in Python. So, but again, something you can check out. I figure it would be something cool to look at and maybe post about in the discussion boards. So those are different examples of using object-oriented programming and data structures. There's also some more. Some of these get a little bit off the beaten path, but I figured they'd be at least interesting things that I think that apply, things that I've used, and things that apply in the business world. So this next one is really cool because when we talk about like why would you actually use data structures. So this is 180 plus algorithm and data structure problems using C++. Now it's C++ instead of something you may have seen a lot of, but it looks just like C#. There isn't much difference. Most of these are relatively simple once you actually get at the code. But the idea of problems are the things that you would get for homework questions, and the reason that those are homework questions are things that you do a lot in programming. Manipulating parts of lists, writing algorithms to see if there's unique characters or if things are duplicates, reversing a set of data, moving or cutting out parts of sets of data. This is a whole series of. Don't obviously expect you to look through all of them and read through all of them, but I'll ask some random questions about generic stuff related to these things like trees, stacks and queues, and so on. Maybe I'll reference something in here that you can look up online. But the idea is to look through these, check them out, try to find some stuff that looks cool. Hopefully by now I've shown you at least different stuff in programming that makes some of this stuff interesting. And the idea is to keep all this stuff somewhere. Like I have this as a list, for instance, in Google Docs, so that you have them in the future when you want to do stuff too. Read through it to understand object-oriented programming and data structures, but they're also hopefully resources for you in the future. This one is another one in Angular and Breeze. These are some cool templating systems that are relatively easy to use. It's just Node, basically. After that, once you get everything installed, you install Node and Gulp, and when that's done, you've got master detail views, a full basically application of like hiring temps, like how you would add people, log them in, and that kind of thing. So next one is Universal Business Language Example Documents. This was something that's a little bit different, but I just wanted to show another example of objects. UBL is kind of like UML. You may have heard of that, Universal Modeling Languages, right, for databases. There's examples of these in XML and JSON, and basically this is a universal business language similar to what Microsoft is trying to do with the common data model. So let's say an example, a debt note or a credit note. When was it issued? When does it start? What's the invoice period? What additional documents? What's the name of this party? Their address? Some standard way to define objects. So the idea here is when you're doing credit cards or wire transfers or debit cards or checks or all these different kinds of transactions, at some point businesses would like to standardize that and be able to process those things automatically. So in a lot of cases right now, if I'm a business and I hire out for other services, whether that be cleaning services, special consulting services, which may be things that my internal staff don't have expertise on. Those items in most cases may be invoiced via email with a PDF attached, or typically everything isn't easily automated from party to party. It could be, and it could be done using things like this. So this is what you're going to see in the future, and more and more of business language definition and things like XML, JSON, possibly more in JSON than XML. I don't know. It depends on what you're working with and what people decide. But either way, you're going to see these objects. This postal address is an object. Inside the postal address is an ID object. The postal address is a sub-object of the accounting supplier party, right? So a series of objects within objects. So just trying to reinforce that, give you some examples to look at of how those kind of things work. So those are examples. One of the other things I wanted to make sure that everyone understands as part of object-oriented programming is the importance of that versus functional programming. So these articles talk about functional programming versus object-oriented programming. They not really too heavy stuff. Should be easy to run through and read to help describe to you the difference and uses also here in this case of objects and procedural and what is correct. So these I want you to read through. I don't want to describe them in exquisite detail. I'd like you to check them out. Explaining kind of what I've been trying to get at about how objects should be done. Next is sorting algorithms, and these are some really cool videos. Again, I'll leave them to you to watch them. They're really, really well done. I love these the best out of all the sorting algorithm videos that I've looked at. I try to look at a lot of this stuff on YouTube to see what I can link to that helps describe stuff. These little robot guys are really great. I have no idea why I haven't subscribed to them. I should be liking every single one of them. I will do that because they're awesome. Go through and check those out because they're a good introduction into sorting algorithms. This is another great one. It goes through bubble sort. The idea of bubble sort is the larger values are supposed to bubble to the top. This is another representation of it. I like the robots the best, but there's a couple of them to check that out. Sorting algorithms, And then all of these, they're in the other textbook, and I know we've talked about them before, but here's another implementation of all kinds of algorithms: bubble sort, insertion sort, merge, quick, and all of them done, selection sort. This is another thing that I wish that we had more time, that we could have done more stuff in person with. But these are different kinds of search algorithms, different ways to do sorting. They're best viewed like in action, like watching the videos and that kind of stuff. So check out that stuff, and then I have a little bit of bonus stuff that I thought was cool. Actually, really one topic. Using Windows Subsystem and Linux. On this machine, I have Ubuntu set up, and Crusader. I thought that was. Let's see. This is my Ubuntu command shell, and I can run. Let's see if it allows me to open. I can run X window applications. I thought it was Crusader. Let's see, apt get install. Oops. I'm not sure what's up with that. There we go. So this is an Ubuntu X window application running in Windows. So I can run Ubuntu applications. I could run Linux applications. I could run Linux X window apps right in Windows itself. These are both separate X window apps. I could install anything basically that I would want. I have apt-get like normal. Basically, I have my own Ubuntu shell, right? I'm running this. So some of you may have seen this. Super cool. It allows you to run basically Linux apps right in Windows. So to do this, I run this command in PowerShell. So I open up PowerShell, right click as administrator. I've already run it, but I copy this, paste in PowerShell, run that command. After I do that, super easy. This is my favorite part of it. I go to the Windows Store, and I search for Linux. And then I can just pick it. Kali Linux, very popular, secured. I picked Ubuntu for this machine because I was working on cloning what GoDaddy has on a certain server I have installed, and they have Ubuntu 18.04 LTS server, so I was going to do something with that on this machine. But you could put Kali Linux on here, right, if you want to. You can put Ubuntu on here. I'm sure there's a KDE, Debian, all kinds of awesome stuff. So after you do that, you install whichever Linux you want. After that's done, this article shows you how to set up to run the X Windows apps. So it's very easy. This Xming, this is linked to from here also. Xming latest files. This is running down here. That's my X Windows server. So basically, Ubuntu is installed. Xming is running right in Windows itself. So it's serving these Windows right here in Windows. So it's basically like a sub window in Windows. Very, very cool that I can run all this stuff from here. Super awesome that Microsoft has this working so well too. Very, very, very cool. Like 2 seconds to do that. You install Windows, or excuse me, install the Windows subsystem for Linux from that PowerShell command. Install the distribution from the Windows Store. Then install this Windows server. Then it's running in the corner. Then you just install whatever app it is you want. In this case, they show a GTK version of Vim, which is a simple editor, and then export this display 0 to your .rc file, and then you should be good. That really was all it took. After that, then I could run these X Windows apps right here in Windows. So super cool. Thought that was a fun thing. All the links about that are here. So check out the stuff. Let me know if you have any issues. I'll be here to help. Also, if you want to check out the Windows subsystem for Linux and have any issues with that, let me know and I'll help you out. And I'll talk to you next week.